Now that $2 million invested right here, the reason this works is because if you invest $2 million at 6% for a year, at the end of the year you got your $2 million plus you have $2 million times 6%, which is the $120,000 that you need to go fix the dam, and that means you still got your $2 million in the bank ready for the next year's work. It'll sit there and compound interest for you for another year, so that you'll have $120,000 here, and at the end of the year you'll have $120,000 and $120,000 until forever. Now, so you have a second project. Project 2, we need $10,000 for repairs of something each month. At 6% nominal interest rate, we have got the bank, since we're going to go in the bank every month, we're going to compound monthly. We've got him to agree to that. How much do we need to extract from the taxpayers? It works the same. The only difference is you'll notice the units change. The present value that you will need to invest is equal to your annual amount you intend to extract divided by the interest rate that you've been given. The amount you need to extract is $10,000 taken out of the bank each month, and therefore this month thing you're going to have to be careful with. That means he's giving you 6% a year, so you multiply that times 1 year for every 12 months, and that means that the bank is willing to pay you 0.5% a month on your money. Therefore, $10 million a month divided by 0.5% a month, look at that, you still need exactly $2 million. Why will it work? Because if you invest $2 million at a nominal rate of 6% a year, which is really 0.5% a month, since the bank was kind enough to compound monthly, then you multiply the $2 million times the 0.5% a month, and it gives you, I got 100,000 here. Let's see about that. Okay, typo, 10,000. Multiply 2 million times 0.05, you get 10,000 a month to make your repairs. Now, the Project 1 bank was only willing to pay us 6% compounded yearly. So that's how we had to wait till the end of the year. That's why we did that, to get our money. The Project 2 bank is a nicer bank. They're willing to compound monthly, letting us take out $10,000 each month. That's a better deal. As a matter of fact, the second bank is giving us an effective interest rate, which we can find right out of the tables, right out of the equations, right out of the book, reference manual. 1 plus R over M raised to the M value minus 1. That's 1 plus the rate, the nominal rate. The nominal rate is 6% divided by 12 compounding periods, raised to the number of compounding periods. So they're giving us 6.16% interest. Now, well, phooey, if he's going to give us a better deal, let's just take the project to him. If he's going to give us a better deal, what we will do is take how much we need. We need $120,000 a year divided by the interest rate, and this is the effective interest rate per year. And now then, instead of having to come up with $2 million, we only have to come up with $1.9 million in order to fund Project 1. Saves us a little money. Matter of fact, saves us $54,000 on that bond issue. But about now, Bank 3 calls up and say, whoa, you're talking $2 million investment? We'll give you 6% compounded weekly. I can do that. The effective interest rate is 1 plus the nominal rate divided by 52 weeks in a year raised to 52 weeks in a year. That's 6.17. It's a little better than 6.16. Not a lot, but money's money. So I'll have to come up with $101.941 million. And if we go to a bank that pays us continuously, I find the effective interest rate from the equation in the reference manual, e to the r minus 1, so e to the 0.06 minus 1, and now I only need $1.94 million, save about $1,000 over this guy's offer. Alright, here's Project 3. A&M's been told they may win the bid to house the Bush Library if they guarantee they can fund the upkeep and repairs in perpetuity. Well, what they expect is $2,000 every 2 months, you're going to need light bulbs. $100,000 every 6 months, you're going to need minor repairs. And $5 million every 5 years, you're going to have to completely refurbish the facility. The government says, we may decide you're the winner, but you're going to have to go put the money in the bank right now so we don't find out later that the Bush Library turns into a trash heap and you can't afford to fix it up. Put it in the bank now. We need to know how much we have to deposit today to guarantee the funding of these expenses forever. And I'm going to assume a nominal interest rate of 6% compounded monthly. The only reason I'm doing monthly is because I got to take money out monthly, and I could do that, with any other way. I would just have to use an effective interest rate. But we're going to assume the bank that we select will compound monthly. Here's a picture. P is equal to, I don't know, but it's going to be a lot. A1 is $5 million every 1, 2, 3, 4, 5 years. A2 is $100,000 every year, and light bulbs is $2,000 every 2 months. Now, problems like this, the easiest way to work such a problem is just to bring all of these annuities and treat them as if they are some future value that you need somewhere down the road, and change it into an equivalent annuity based on the compounding period. For example, let's just do one of these. How much money would you have to invest each month? Because that's the compounding period. You say we're taking money out every 2 months, doesn't matter. Say we're taking money out every 12 months, doesn't matter. Taking out money every 5 years, I don't care. The bank pays compounded monthly, therefore that's the period, the compounding period I'm going to use. And one of the problems listed above is to have $100,000 ready at the end of a 12-month period. That's easily found by taking the future value needed and transforming it into an equivalent monthly annuity. The nice thing about an annuity is once you get the annuity funded, then it's good forever. You don't have to worry about, can you take care of this one by bringing its value here? Yes, but then you got another one down the road that you have to bring back, and there's so many of them down there you can't bring them all back. So you change this into an annuity, a monthly annuity, because the bank's going to pay me compound monthly. Alright. The interest rate that he's willing to give me per payment period is 6%. That's the nominal rate divided by 12. So the bank is willing to cough up 0.5% per month. And A2 can be funded in perpetuity by taking the value I need, that's the future value I need. The future value is the 100,000, multiplying it times A over F at the I per payment period for N periods. So I use the A over F column. I use the 0.005, the 0.5% table. I said we'd always use the 6% table, but this time we're going to have to use the 0.5% table, and we're going for 12 payments. So, if you multiply 100,000 times that number, what you'll find is you have to you have to give the bank $8,110 each month. Now what he's saying is if you'll invest $8,100 in my bank as an annual amount, remember you must follow the rules. The first deposit goes in at the end of the first month for a total of 12 months. Then you'll have $100,000 at the end of that 12-month period, and then you can withdraw all the money you put in my bank and make your repairs as necessary. And since you intend to cough up the same annuity for the next 12 months, at the end of that 12 months, you will again be able to fund your necessary repairs of $100,000. So by depositing $8,110 once, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 times, at the end of that time, I'll give you $100,000. Come by the bank and pick it up. You can go make your repairs. At the end of the next month, you put in another $8,110 at the end of that month. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That will let you take care of this amount needed. All right. Now then, having deposited that amount, you will always be able to get the $100,000 necessary at the end of each year. Now let's do the same thing to that A3 guy. Don't forget that the compounding period is monthly. So we set the future value needed. Well, the future value is $2,000, and we need it every 2 months. And since we're being paid 0.5% per period, we have 2 periods to get our money together. We would say that an annual amount of investment into the bank could be found by taking how much you need in the future. What you need in the future is $2,000. And the A over F column is the tabular number you're looking for. In that column, 0.5%. Notice now you only have 2 payments to make the thing. You may think you're looking in the 2-year row, but you're really not. You're looking in the 2 payments row. That number is 0.4988. You multiply 2,000 times 0.4988. He's saying if you put $997.60 in my bank twice, then I will allow you to extract $2,000 at the end of those payments, and you'll have the $2,000 you need. And then at the end of the next month, you put in $997 and $997, and it'll give you another $2,000. And so again, you'll see I'm really finding the annuity, the annual amount that I need to invest in order to get the withdrawal I need. It's getting kind of close to the end of the tape. I'm going to go ahead and change it so I won't forget.